A machinist is required to manufacture a circular metal disc with area 1,000 square centimeters. What radius produces such a disc? We'll start with the formula for the area of a circle, pi r squared. And in this case, we're told that the area is 1,000 square centimeters. Solving for r, we divide by pi. And then take the square root to get r is the square root of 1,000 divided by pi. If the machinist is allowed an error tolerance of plus or minus 5 square centimeters in the area of the disk, how close to the ideal radius in part A must the machinist control the radius? We can think of this in terms of the epsilon delta problems that we've been looking at up to this point. So think of the area as your function, and if we subtract the limit or the ideal area, we want that to be less than or equal to our epsilon, which in this case is the error tolerance of 5 square centimeters. Now we have an absolute value inequality. To solve this, we make the left side negative, copy the inside but drop the bars, and keep the 5 on the right. We'll add 1,000 to both sides. And we can translate the a back into pi r squared. And now we're solving for r. Divide by pi. And take the square root of both sides and the middle. So we have our bounds on r. Think of these as the x1 and x2 that we've seen in the previous problems. To find delta 1, we're going to take the ideal radius, which is 1,000 over pi, minus x1, or the square root of 995 over pi. If we throw this into the calculator, we get that delta 1 is roughly 0.04466. Delta 2 is our x2, which we found to be 1,005 over pi, minus the ideal radius, which is 1,000 over pi. Approximating this, we get that delta 2 is roughly 0.04455. And we want the smaller of these, so delta is roughly delta 2, which is 0.04455. So what this means is if the machinist gets the radius to within 0.04455 centimeters, the area will be within the 5 square centimeter of the ideal 1,000 square centimeter area. So in terms of epsilon and delta, let's look at the different pieces. What is f of x? F of x, as we said earlier, is the area. What is a? A is the target radius, that ideal radius. What is L? L in this case is the target area. And what is epsilon? Epsilon is the tolerance in our area, the 5 square centimeters. And what is the corresponding value of delta? That was the tolerance in the radius.